Come on. All right, so I kind of like today, like I said, a little bit better than some of the super wordy sections, because this one we're going to have some nice tables to get some numbers and literally get our probabilities off of that. Remember, probability, we're always calculating some fractions. We're going to start getting those off of these tables. So you can see right away, we're going to kick it off. There's an example of a two-way table. Now, why two-way table? Because you're comparing two types of data. You're comparing whether you're left and right-handed on the vertical column, and then you're comparing if you're male or female on the horizontal. You're comparing two different types of data. So you can see it there. So first off, we need to figure out the total. So I'm just going to do the columns first. Left-handed, 7 plus 9, 16. Probably going to need your calculator for this. What's 48 plus 86? Got it. Now I'm going to do the horizontal. I'm going to do 7 plus 48. What's 7 plus 48? 55. What's 9 plus 86? Okay, question. Does it matter for this bottom right corner number if I had the 55 and 95 or the 16 and the 134? No, because they're both the same. What are the totals? 150. So, of course, we got to talk about the vocab because they're going to throw some vocab at you. So the joint frequencies are your individual data entries. And then it says the marginal or the sums. Okay, so just to kind of color code it here for you, the joint ones, the individual data entries. So these numbers are what we call the joint frequencies. And then all of the totals on the bottom are what we call marginal frequencies. So the 16, the 134, all of this are called marginal frequencies. So that's just some vocabulary. You're going to see those words. Now, like I said, we're going to practice filling in some tables, and eventually we're going to use the tables to calculate probabilities. I see some of you already filling in the next table, so let's get to it. So upon exiting, passengers on a plane were asked if this was their final destination and if they checked any bags. The results are shown in the table below. Complete the table by filling in the missing joint and marginal frequencies. All right, doesn't matter how you fill them in, we just need them all. I'm going to start with this total. What's 50 plus 16? Got it. How are we going to figure out this one here? Subtract. What's 136 minus 50? Got it. What's the total of 16 and 48? And our grand total. Have you filled in tables like this before ever or no? Just curious. Yeah, okay. So no big deal. All right, now, again, we're using the tables. We're working our way up to what we call calculating probability, of course. So now we're going to, more vocab for you. So relative frequencies. So reading the top, the values in each category divided by the total. That's the key. Marginal relative frequencies. They're throwing the word relative in there. The sum of the joint, blah, 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 in each row and each column. So here's what we're going to do, and I'm going to have to click it back to the previous one because we're going to need it. You have it right in front of you, obviously. So if I want to make my next table the relative frequencies, that means they want you to go through and take every number in this table and divide it by the total. Well, what's our grand total? 200. So I'm going to divide all of these numbers by 200. So I'm going to do 50 divided by 200, 16 divided by 200, 66 divided by 2. You get the gist, okay? So you don't have to write this part. I'm just going to write a few down so you know what I'm doing here. Decimals. Let's go decimals. What's 50 divided by 200? And you don't have to write the 50 over 200. I'm just doing it for the first couple so you know how I did it. What's 16 over 200? Now, you could just straight add those together if you wanted to add 0.25 or 0.08, or of course you could do 66 over 200. Either way you cut it, what's your total here? Point. All right, let's keep going. So this one you had 86 in it. What's 86 over 200? What's 48 over 200? 0.24. And I would just add those because I can do that in my head. Oh gosh. I'm not going to say it out loud. I'm just going to write it. Okay. All right. What's 136 over 200? Or you could add these together, of course, to get those, however you want to do it. What's this one? Point. And this guy. 1. Now, why do they make you do these? Okay, because I mean, we're pretty good at dividing in here for our probabilities. So now I could look at this super fast. If I asked you, what's the probability that you didn't check a bag and it did make it to the final destination? 8%. I can tell you right now, I can just look at it. What's the probability you checked the bag and it didn't make it to the final destination? 43%. Now, I mean, I could have just divided the numbers from the previous table and got that for you, but it's just to kind of make it a little simpler for you so they're all right there in front of you. So now flip the page, we're actually going to calculate some probabilities. So students in band were asked if they rented or owned their instrument and if they practiced at home. The results are shown below. If the students chosen at random, find the probability. Well, we're probably, before I do anything, going to need our grand total. You only need the total. So let's add all of this up together. So it's 62 plus 20 plus 28 plus 15. 125. We need the grand total of how many kids. They didn't tell you that. So I know all of these fractions, I like to do the total first, is going to be over 125. All right, let's get to the first one. So probability does not practice. How many total kids don't practice at all? Before you can get to that, just give me the number. 43. So does not practice is my 28 and my 15, or 43. And you could leave it like that. It doesn't reduce. If you want to give a percent, I heard 34%. Doesn't matter to me. Do what you want. Okay, practice and rents. 62. Now, 62 over 125 doesn't reduce. You could leave it just as it is. If you want to give a decimal percent, you do you. I don't care, whatever. Okay, let's look at this. Now, notice I didn't right away fill in the totals on these because it's like, oh boy. As soon as I see this, conditional probability. That's what we did yesterday. So I'm like, okay, that means I'm going to have two fractions. I know both fractions will be over 125, but this is now yesterday's throwback mixed in here. So we got to read closely. So first I need you to tell me how many do not practice and own. Don't practice and own. 15. Okay, the bottom one. I know it's out of 125. Now we just do the probability of the second event. So how many total people own? 35. 20 and 15, 35. Now, we saw the shortcut yesterday. When those are both over 125, we know they cancel. So I'm going to go right to 15 over 35. Does that reduce? Yes, 3 over 7. Love it. So again, soon as I see this, I'm like, oh boy, that's yesterday. That's the conditional fractions. That's going to be two fractions. So that's why I didn't get crazy and just put the 125 in yet. So let's do the top. Rents and practices. How many rents and practices? 62. Get it right off the chart. No magic here. Bottom probability is the second event, just practices. So how many total practice? 82. 62 and 20, 82. Now, we know the shortcut because we're smart in here. Those 125s cancel. I'm down to 62 over 82. Does that reduce? Yeah, both even, so at least 2 is going to go into them. 2 goes in 31, 41. I can't go any further because 31 and 41 are what special types of numbers that are over here. Right. So I almost like today better because, you get those numbers quick and easy right off the table. All right, let's do another here. So a test was given to 3 classes. The results of the test are shown below. If a student from one of the classes, blah, 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 find the probability. So, of course, we need the total. Total that all up. I need to know how many total kids are we talking about. So it's 19 plus 24 plus 21. Add them all up. 80. Okay, so first one. Probability class B. Now, I see no crazy conditional on it, so I know it's a single fraction. I'm going to be just over 80. Okay, now in class B. So let's total up how many kids are in class B. 32, 24 plus 8. Does 32 over 80 simplify? Of course, right? 2 over 5. Okay, now I like this one. I don't see the conditional, so I know a nice, easy little fraction, just over 80. So I'm going to take a look over there. How many are in class C or past? All right, okay. So here's my class C. You can add those together here at what? And we also have to add on what? Yeah, our past. So I need the 19 and 24. So I have to add 19, 24, 21, 25. I need all of that combined, which is a total of, I hear different answers. 69. Does that reduce? No, good adding, Graydon. Okay, now I'm like, oh, gotcha. Okay, here we go. Conditional probability, two fractions, get psyched. So we know we're over 80. So just like yesterday, did not pass and in class A. How many did not pass and are in class A? 3. That's easy. I like that one, right? Okay, bottom one. Now, just the probability of the second event. How many total are in class A? 22. 22. It's all right. So we've got 3. We know the 80s are going to cancel, so we're down to 3 over 22. Does 3 over 22 reduce? No. All right, final hurrah here. So of course we know we're over 80. Class B and past. How many are in class B and past? 24. Good. The bottom is the probability of the second event. How many total passed? Good. Because you have to add 19, 24, 21 to get the total amount that passed, which is 64. All right, so we are down to 24 over 64, which does reduce down to 3 over 8. Good. I hope, does probability seem like it's getting a little easier? A little bit, I hope. Okay, last one. And it's more of the same, people. Now, here we go. You're going to need your calculators for sure. A restaurant has chocolate, strawberry, and vanilla ice cream available in a cup or cone. The table to the left, this guy they're talking about, gives the choices for the last 200 people. Total 200 people. Okay, I'm going to keep reading here. Who ordered ice cream. Complete the table below with the joint and marginal relative frequencies, then find each probability. So you're like, okay, wait, I'm doing what here? So remember, this is the key word, relative frequencies. That is where we're going to take all those numbers and I'm going to divide them all by what? 200, the total. So what's 42? You don't have to write them all. What's 42 over 200 is a decimal. Got it. What's 28 over 200? What's, I'm doing the vanilla now. What's 18 over 200? I'm going to do the bottoms in a minute. Let's just get these first numbers done. What's 55 over 200? I heard 275, 28. Does it really matter? Yeah. I don't know if I can fit 75, so I'm going 28. What is 22 over 200? And this one. Point. So I'm going to round it, just because I know I can fit in there. Now, we're going to have to do the totals, but I mean, we can add, right? We have our calculators. What's 0.21 plus 0.14 plus 0.09? What's your total error? What's 0.28 plus 0.11 plus 0.18? All right, keep going. I'm going to go across now. What's 0.21 plus 0.28? What's 0.14 plus 0.11? 0.25. What's 0.09 plus 0.18? And what do you get when you add these all together? 1. Now, we might be not quite at 1 because I did what? I rounded. I rounded a little bit. Because remember, this was like 0.175. I rounded because I couldn't fit it in there. Okay. But if you do the 1.175, it will turn out to 1. Now, I don't know. I have a love-hate with that relative table. Because did I really need to make that to do any of the other previous problems? No. Okay, I can divide all on my own. But, you know, it is allegedly supposed to make our lives easier. We should be able to get our answers right from this table now because we did all dividing already. What's the probability that you get a cone? So take a look at your cone. What's the total in the cone? 57.57. Or 57%. I know some of you like the percent. So I just right here. Okay, B. What's the probability that it's a cup or chocolate? So I had to take the total for the cups and I'm going to write the total for the cups here and any of the chocolate stuff. But hang on a sec. When I go to look at the chocolates, am I going to add another 0.21 in here? No, because I already have that in the total for the cup. But I also need the 0.28. Okay, add that up. What do you got? 0.72, or if you like a percent. With us. So just be careful, of course, when you're adding. All right, here we go. We are going to do a little dividing because, of course, conditional. Got to. All right, let's start with strawberry and cone. What's your number for strawberry and cone? Strawberry and cone. 0.11. Okay, probability for just a cone. What's your total on cones? 0.57, which we just did right above it. Okay, that you're going to have to divide out in your calculator. What do you got for that? 0.19, 19% if you like that. You do you. All right, final one, and we have made it. Okay, cup and not vanilla. So cup, not vanilla. So that means you're looking at chocolate and strawberry here in the cup. What do you get when you add those? 0.35. Okay, the bottom, probability not vanilla. Now, probably the easiest way to do it here. So, I mean, I guess you could add a bunch of stuff if you wanted to. You could subtract off the vanillas. It's totally up to you. So I'm looking at like my vanilla total. So my vanilla total for cup and cone, I'm looking at this guy here, is 0.27. So probably I think the easiest, I'm going to do the complement. If the probability of getting vanilla is 0.27, not vanilla, I would subtract it from 100%. I'd subtract it from 1. So what's 1 minus 0.27? And then I divided that out. But you could also add 2 if you wanted. I was just trying to be smart about it, make it easy on myself. What's 0.35 divided by 0.73? Final answer? 48 or 48% if you like, whatever. Got it. We did it, guys.